Hello students. Today we're going to be talking about systems of equations. That is just working with two equations and two unknowns. So we're just adding another step on the ladder on our equations. And these questions will be on the HiSET test. So good time to learn how to solve a system of equations. And there'll be several different kinds. These are the first of the batch. This is your definition. System of equations. Two or more equations that are solved together at the same time. So we'll be working them together. One solution may solve everything. Isn't that good? Okay, so let's do an example. Write down your definition. Definitions are important. Vocabulary is important. All right, so let's say we have, let's just use the unknowns x and y. So we have x plus y equal 13. And then we have x minus y equals 1. Okay, so we want to know what x stands for and what y stands for. How can we go about this? Well, we can solve for one of the unknowns. So, let's look here at this. Negative y and positive y cancel each other out, don't we? They're not there anymore. So we can solve for our x variable. So x and x give me a total of 2x equal, since I don't have this, I don't bring that down. 13 and 1. Okay, so I've got a nice one-step equation here. 2 times some amount equals 14. Okay, so we know what that is, don't we? But let's go ahead and work it out. Since 2 is related to your variable or your unknown x, do the opposite of multiply, which is to divide each side by 2. Because what we do on one side of our equation, we always do on the other side, okay? If you do it here, you gotta do it over here. Gotta keep it in balance. So that cancels that one out. I have my unknown x, 14 divided by 2. Okay, so now I know that x stands for the amount of 7. But what does y stand for? Easy. We're going to just take one of these equations up here. Let's just go ahead and let's just take the top one, okay? X plus y equal 13. So I'm going to write it right here. X plus y equal 13. Well, I know that x is 7. So where I have this x, I'm going to substitute a 7. Okay? 7 plus y equal 13. Now I just have the one unknown to solve for, the y. 7 is a positive number. To get rid of it, I could put a negative 7. 7 takes 7 away, it's out of there, right? Cancel that little buddy out. But if I subtract 7 on this side of my equal sign, I must go over here and also subtract 7. Now I have my y isolated. It's all by itself. 13 takes 7 away, leaves me with my answer, 6. So x is going to equal 7 and y is going to equal 6. Let's see if it works. Let's go back up here and check ourselves. So if x is 7 and y is 6, that works, correct? Let's try the next one. X is 7 minus y is 6 equals 1. 7 minus 6 equals 1 works in both equations. So we have solved that system of equations. When you see something like that, you go, huh, easy peasy, I can do that. Let's do another one. Once again, we're just solving the pieces of the puzzle, aren't we? What goes in that piece? What goes in that spot? We can figure it out. Puzzles are fun. Let's do one with, some bigger numbers in it. Okay, let's do 3a plus 2y equal 26, and 3a minus 2y equal 10. Okay, so we just have some numbers attached to our unknowns. That's okay, we can work those, can't we? All right. Let's look at both equations. Is there anything I can cancel out? That's your first thing to look for. Ooh, I do see something. Positive 2y and a negative 2y. They're out of there. I'm just going to line through it because I don't need that right now. So now I just have my a here to solve for. So I have 3a here and 3a here. That gives me a total of 6a. Because I can add like terms together, remember? Put all those little critters in the pen together. Equals 26 and 10. Okay, now I'm down to a one-step equation. 6 is related to a by multiplying. So to isolate that a, I want to get rid of the 6. To get rid of that 6, I have to do the opposite of multiplying, which is to divide by 6. Remember, anything I do on one side of the equal sign, I've got to do the exact same thing on the other side. So I've gotten rid of my 6 here. I've isolated my unknown a. 36 divided by 6 is 6, because 6 times 6 is 36. So now I know that a represents the amount of 6. Now I need to see what y is. What does y equal? So let's take one of our equations. Let's go ahead and just take the bottom one here. It doesn't matter which one you use. Either one, okay. So let's say 3a minus 2y equal 10. Okay, since a is 6, we're going to substitute a 6 right here for the a. And I'm going to put that 6 in parentheses to show that we are multiplying, and it won't look like the number 36. So 3 times 6 minus 2y equal 10. 3 times 6, 18 minus 2y equal 10. Okay, I want to get rid of that 18. To get rid of it, I have to do the opposite of what it is. It's a positive 18. To get rid of it, subtract 18. And it's gone. But if I subtract 18 here, I must also go to this side and subtract 18, right? We may run out of room, hope not. Okay, so now I have negative 2y equal 10, take 18 away. Let's say if I have 10, but I need to give you $18, I still owe you 8 more, even though I gave you the 10, right? So we're going to still owe $8 here, negative 8. 10 minus 18 throws us in the end zone, negative 8. All right, now I have a negative 2 connected to my unknown y. It's related to the unknown y by multiplying. The opposite of multiply is to divide. So I will divide right here by a negative 2, and I can cancel it out. But if I divide this side by negative 2, I must jump the equal sign and divide the other side by negative 2. Okay, now I have my y isolated. So y is going to equal negative 8 divided by negative 2. Remember, 2 wrongs make a right if you multiply or divide by negatives. So, negative 8 divided by negative 2 gives me a positive 4. Okay? So, we know that a is 6 and y is 4. Let's go back and plug it in and just kind of check it, just for fun. Okay? So, if a is 6, and y is 4. 3 times 6 is 18. 2 times 4 is 8. 18 plus 8, that does equal 26, so that one checks. Let's try it on our next one here. A equals 6. Y equals 4. Okay, 3 times 6 is 18. Minus 2 times 4 is 8. 18, take 8 away, leaves me with 10, check. So our solution for our unknowns solves both equations. We've solved that system of equations. Okay, I'm going to give you some worksheets to practice on those. Next video, we're going to do some a little bit differently, a little more challenging. And we will do some word problems involving systems of equations, which those are super fun. Okay, see y'all next time.